Hi, my name is Erika Simon, and I would like to talk about the project I've been working on for about a year now. This project is called the LIBI engine. It's a 3D engine for Android devices running entirely in C++ and using the Vulkan API for the graphics. As such, it should also run on a PC without much change to the code. In this video, I'm recording my Samsung Tab S3 running said engine. So first and foremost, this engine has two peculiarities. The first one is that it uses 3 threads running in parallel, asynchronously. So the first thread builds the environment, the second thread does the animation and the physics, and the third one the graphics. The second peculiarity of this engine is that it is working on the nonlinear topology model that I've developed for the 3D rendering. I'll talk more about it later on. So, about my choice for Vulkan API. Yes, first of all, the obvious reason is that it's more flexible and offer better performance than other API. The second reason is that it's cross-platform, and as a matter of fact, I would like to make an engine that can run both on Android and on PC. And finally, but also very importantly, is the fact that Vulkan API allow for a very large amount of draw calls without much overhead on the CPU, which is something that is quite required in the case of my engine. I will later on explain why. So first, let's talk about the video in itself. So you can see light orb moving around inside a tunnel and casting shadows in the environment. The tunnel itself is more or less infinite, as it is built little by little by connecting random pieces of structures to it in a seamless manner. About the shaders in itself, it's a physics-based material, so you can do metals, plastic, coating, roughness, all kind of stuff. And furthermore, the specular is done on a pixel level and can support up to 4 light sources. Otherwise, we have the mapping, and as it's not as obvious on video, but I can do real-time environment mapping. In the present case, since I didn't want to undermine the performances, I decided to just do a snapshot at the beginning of the application, and then just keep on using the same snapshot for all the reflection on the objects. About the shadows, we have point light shadows, as can be seen in the video, but the engine also supports sun shadows. Otherwise, we have refraction effects going on. You can see them on columns and on the crystals in the environment here. It's also used for the water in the present case, as I have not yet developed water shader, but I will do so in the future. Otherwise, we have volumetric particles, as is the orb in itself, and although not visible in this video, I've developed an experimental shader for smoke effects that I will also show later on. Let's talk about the rendering technique I developed. It's based on some nonlinear formulas I've come up with to deform objects of any shapes along complex curved surfaces, which allow me to basically tile a complex environment with any kind of structures. And the advantages of such technique is that it allows me, as you can see in the video, to render very complex environments without much memory usage on the GPU. Another advantage of this method is that I can do local level change in the level of details of the structure. So it is both memory efficient and very performance effective. Otherwise, this technique allows for modification of the structure without having to reloading the models to the GPU, and it's also quite easy to build structure that way, although it's not obvious in this video. And finally, since the formula allows for soft deformation of the object, it should come in very handy when doing animation. And finally, but also quite importantly, this technique preserves very accurate bump mapping, which is why we have such seamless mapping in the structures on the environment. To give you an idea about the memory impact, in the present video, the tunnel is made up of 3 different kind of samples which is basically squares defining the surfaces. Each surface is about 1,500 triangles for a total of 10 megabytes of samples. The structure itself also is about 1 megabyte heavy. And so for combined 11 megabytes on the GPU memory. To give you an idea, this is about 2 million triangles, and on Houdini, which is the software used for modelizing stuff, it would come up to about 250 megabytes even instead. So we can see that on the GPU memory, we go from 250 megabytes to 11 megabytes. And furthermore, if we want to reuse the same samples for different kind of structures, this structure will only be about 1 megabyte per 1,000 instances. So it's very memory efficient. About the performances. So as you can see in the video, this on the Snapdragon 820 that was released in 2016, it runs at about 20-30 FPS at a screen resolution of 720p. It's not great, it's not incredibly smooth, but then again it's running on a mobile device and can probably still be improved. I've also made sure that the engine run on the Exynos architecture, in the present case the 9810, which was released in 2018. It runs a little bit better than on a Snapdragon, which is much older, but it's not as stable. And the reason for that is that the Exynos architecture uses Mali for GPU, and this one does not support multi-draw indirect. And yeah, that's not ideal and actually quite a shame. So I had to use PCOs for the drawings, and yeah, it's not great. So I'll try to move on to instancing to see if it improves the performances on the Mali GPU for the Exynos. I was saying earlier that you need a lot of draw calls. So as a matter of fact, in this scene, you have on average 1,500 draw calls for each frame, which is why I really need the Vulkan API for such application. Additionally, this engine can handle basic physics such as multiple collision. I use the impulse method for that. In this video, I'm not showcasing it because when I implemented the physics, I was still using the classic rendering methods, and so I would have to modify the physics to support a nonlinear deformation of the objects. Otherwise, it's not very obvious in this video, but I use a 3D noise lattice to introduce noise and diversity in the environment. In the present case, it's basically changing the color. And finally, yes, so to give you an idea about the size of the engine right now, it's I had to write about 25,000 lines of code, maybe a little bit more if you include the shaders. So it is quite big, but it should not get that much bigger. It's really quite decent as it is, basically. And finally, so to explain what I'll be doing from now on, first and foremost, as I was saying, I need to improve the performance on the Mali GPUs, so I'll try to use instancing for that. I also need to improve the texture handling on the shader level, so yeah, I'll be working on that as well. And yes, I need to modify the physics so it works better with nonlinear objects. And otherwise, yes, I would like to implement some draw system for object far away, because in this conversion the draw distance is only 200 meters, which is definitely not enough if I want to make mountains and more interesting environments. Otherwise, yes, as I was saying earlier, this has been developed for Android, but I'm also considering switching to PC for further development. On this subject, I'll be going on forum and checking with interested people what they prefer I do. And finally, yes, this video was not very interesting. I mean, the environment is not all that thrilling and it's not very colorful. You don't have much variety, so I need to, create more environment, see how far I can push the technique in itself, and yeah, we'll see what happens. And anyway, that's all for today. Thank you for listening, and I'll try to keep in touch as soon as possible about the progress on the engine. So that's it. See you around.